All right, well, it's 9:02. Let's jump in here. First of all, thank you everyone for joining us today. Wait, let me get my video going. There we are. Axiom hosts a quarterly webinar on how data is being used to transform commercial refrigeration. And so this is our Q2 2023 installation. And so we want to start by highlighting a few items as we get started. As attendees on the webinar today, your camera will be turned off and everyone will be muted. However, if you have questions during the presentation, we ask that you please use the Q&A tab at the bottom of your Zoom screen where you can enter questions. And we've reserved 10 minutes, assuming that we stay on time, for Q&A at the end of the main conversation, and we'll address all the questions that we can at that time. We are recording today's presentation and we're going to make it available when it's ready. If you see or hear anything from our panelists today that you'd like to learn more about or get more information on, feel free to send us an email and we can set up a one-on-one call to discuss more. And really importantly, this is not a sales pitch for Axiom Cloud or for Dalkia Energy Solutions. Instead, this webinar is meant to start an industry conversation. Ideally, retailers and suppliers will learn from our panelists' experiences with both traditional refrigeration energy commissioning and AI-enabled refrigeration energy efficiency. Our goal is to help participants evaluate ways to improve their own maintenance strategies and energy strategies, and there's no silver bullet solution that works for everyone. So let's do a couple of intros here. My name is Amrit Robbins. I'm the CEO and co-founder of Axiom Cloud. I've been helping grocery chains and large commercial refrigerated facilities optimize their refrigeration for about 10 years now. Refrigeration is a massive climate opportunity and financial opportunity. And it's also a really overlooked and underserved category. We started Axiom Cloud a few years ago to solve the biggest problems plaguing the space using software and automation. And so I'll pass it over to you, Will, at Dalkia.
I'm Will Carroll. I do business development here at Dalkia Energy Solutions. I sell, design, and implement energy efficiency projects and programs for customers in the grocery sector.
Awesome. So with that, we do have a couple other folks as well who will speak later on, but let's do those intros a little bit later when that makes sense. So going forward here, our next slide. So our agenda today, we're going to start by giving the quick background on refrigeration energy efficiency. Why should I care and why is now the right time? From there, we're going to talk about the strategies that are being used today, the good, better, and best. And after that, we're going to talk about how really AI plus humans is, in our mind, the key to enabling great energy efficiency practices at scale. And from there, we'll go into some case studies and examples, and we'll reserve the last 10-ish minutes for Q&A. So that's our goal for today. So let's dive right in here. Refrigeration energy efficiency. Why is it important? Grocery stores spend an enormous amount of money on energy, and that's really driven by refrigeration. In fact, every month, groceries are spending more on energy than they take home in profit. So saving $1 on the energy bill has the same impact as adding $1 to the bottom line, of course. But in this case, that dollar that goes to the bottom line is incredibly meaningful because it's already such razor thin margins. And so the Department of Energy has put out some really interesting studies where you save $1 on energy, it's equivalent to selling like $30 of additional grocery or even higher than that. And of course, those numbers change from company to company, but all that to say that there's an enormous amount of leverage and opportunity here from a CFO's perspective when it comes to saving energy. And if you don't have refrigeration under control, you really have missed the entire boat when it comes to energy. And that's because refrigeration accounts for over half the energy consumption in a typical grocery store. And this is an even more magnified opportunity and refrigeration is an even larger portion of the pie when we're talking about cold storage facilities or food processing or packaging facilities. So it goes without saying that refrigeration is the biggest driver of energy. It's also the biggest opportunity for energy efficiency. So the next big question is why now? And I'll pass it over to Will for that.
So yeah, this is an interesting one. I think a lot of our coworkers and customers and utility program administrators have been with us for the last 10 years on this journey, implementing the conversion of fluorescent and HID to LED in the grocery, inside the grocery store. And it's taken, basically 10 years, millions of fixtures across thousands of sites, a ton of bandwidth, mental and otherwise, a lot of budget. Really, it was a pretty big effort, and I don't think that can really be understated. That was a transformative move, delivering hundreds of thousands of kilowatt hour reduction on a per site basis, and all of a sudden it's over. So it's done. All the LED, all the sockets are filled, all the fixtures are changed. There's not going to be a new generation of LED that's going to be compelling in the same way that this transformation was to drive that next level of savings. So there are a whole lot of folks that we've gotten to know pretty well that all of a sudden have some bandwidth and some mental capacity and some budget. And as Amrit said on the last slide, there's the 50% of the store energy consumption elephant in the room. So meaningfully engaging with the refrigeration and HVAC system, where there are tons of things to fix, is a pretty good basis for shifting our focus. So a lot of these, we call it the energy efficiency industrial complex. There's a whole ecosystem of folks that are going to be shifting their focus. And we've been sort of doing this over the last 2 years. And we think, we kind of have this practice up and running right now, but we think that everybody's looking for that next project or program type. So they're looking for repeatable, real, actual savings that are going to deliver, 6-digit kilowatt hour reduction on a per site basis and can be repeatable and scalable. Simultaneously, there's never been more connected devices or visibility into a site, but with that, that tremendous availability of data comes kind of this overload. You've got tons of information, and holy cow, what do you do with it? It's a pretty intimidating task. Layer on top of that, the fact that energy is getting more expensive, and energy efficiency in a refrigeration system very closely tied to refrigerant levels, which are often declining due to leaks. And refrigerant is getting awfully expensive from a regulatory and from a supply perspective. And then lastly, we think that this renewed focus on energy efficiency in the refrigeration and HVAC space is going to coincide pretty closely with, hey, there's a lot of stuff that needs to be fixed, and the folks that are qualified to do this are in very short supply. So how do we use them to their highest and best use to make sure that they're focused on the right stuff? And the right stuff essentially is serving two functions: making sure the food is the right temperature 24 hours a day. That's primary. And along the way, if we can significantly, reduce meaningful kilowatt hours at the site, that would be a great objective too. And we feel like if you focus on the right stuff, you take most of those available chips off the table from a savings perspective.
So that leads to the next question here, which is, what is being done today? What's available? So we have a bunch of really smart people. There's a lot of desire to become more energy efficient. And the last big project of LEDs and doors on cases is, for the most part, done. So what happens next? So there's a bunch of different answers to these questions, and we've kind of bucketed this into a good, better, best framework. And so let's start with the good, assuming that I can get this slide to work. All right, so the good option is retrocommissioning. And really simply, that is hiring a commissioning agent to spend some time on site, going through the fine-tooth comb and reprogramming set points, expecting systems, optimizing across the board. And that can lead to really great performance. But a couple of key questions: will it last, and can it scale? The next option is our better option. And so this is where we're doing the good option, then we're layering in on top of that set point standardization across many sites, as well as set point lockouts to ensure that technicians can't go in and change things after the fact. And so that leads to the question, or, obviously that's going to lead to slightly lower energy savings because we're taking a standardized one-size-fits-all approach across the fleet, but it makes things much easier to manage at scale from an enterprise standpoint. And the other big advantage is that those savings can be sustained quite a bit longer because we are reducing the number of options for the sustainability of savings to be compromised by essentially, making sure that technicians can't go in and change things for better or worse. But that leads to the big question: what if there is a change or an emergency on site? What happens in that situation? And we'll dig into all these, of course. The best option, as we've laid it out here, and of course, this is just our opinion, and we'd love to hear any thoughts or feedback on this in the Q&A, is continuous energy commissioning. And so in this bucket, the way that we think about the world is that we are working to maintain and improve energy efficiency over time while adapting to changing conditions. So seasons, changing what's in the display cases, adding display cases to the lineup, changing ownership of the store, whatever it might be. And so this is going to maximize energy savings, and it's going to maximize sustainability of savings. But the big question here is how much human time is required for this? Like, this is a pretty massive undertaking, especially if humans are doing this. So with that, let's dive into each one of these one by one, starting with good. So retrocommissioning, quick overview here. Like we mentioned, this is involving someone going on site and tuning everything up really, really well, and just having that store humming perfectly when that person leaves the site. And so I guess questions for you, Will: what is the typical scope of an on-site retrocommissioning?
Yeah, so this is nothing new, right? This has been around for decades. There's sort of best practices, and there's clear outcomes that are targeted, and there's a lot of time spent just delivering boilerplate scope. So the scope, hey, there might not actually be a tremendous amount of improvement in this one particular aspect of the scope for this one store, but we're doing it anyway, and it doesn't matter, and we just basically go through the motions. And then on the flip side, possibly there are areas that really demand relatively a lot more attention. And because it's boilerplate, there's not as much flexibility to really spend the time to diagnose, troubleshoot, improve, and permanently adjust the trajectory of that one measure. So it's depending on what your focus is and what the lens is of your recommissioning. This could be 2 days, it could be 2 weeks. And, I think we're constantly asking ourselves, where is the time best spent? Where do we kind of hit that sweet spot of time on site to kilowatt hours, real kilowatt hour savings delivered? And so, anyway, this isn't going away. The going on site with the right skilled person to make these changes, turn the wrench, make the programming adjustment, and be there long enough to make sure that they can actually prove out that something has become better. That this part's not going away, but I think where we're going is, we'll get there.
Yeah, a couple of questions, follow-ups there. Can you talk about sustainability of savings with this approach, and I guess also scalability?
So, this typical model uses a third-party commissioning agent that is typically not the servicing contractor at that store, who has a lived history inside of that facility that the third-party commissioning agent doesn't really have any appreciation for, because they're there to do this very defined scope, and then they're on to the next site. And there's sort of not enough conversation that happens along the way to sort of say, hey, by the way, this one rack, we always have this one issue. It's because of this. So you miss that, and it's just, anyway, that's a bit of a limitation.
Yep. One thing that we say here is that there's a rapid degradation of savings every 2 years. And in many cases, I think that that's a pretty conservative statement. We're seeing rapid degradation of savings over 2 weeks.
Right.
After these recommendations happen.
Typically that's being driven by a set point gets adjusted, something mechanically is adjusted on site to minimize compression ratios. And then typically it's a refrigerant level issue, and it's, hey, there's not enough gas in the tank. We're not able to sustain the low head. We're not able to optimize the float. What do? You just pull it apart as soon as the commissioning agent leaves, don't add the gas, and we're back in the same spot.
Yep. So it gets to the alignment issue of hearing technicians, I've heard this many times in my career. I got hit by a retrocommissioning. So the technician says, I know this site. I've been working on it for a decade. I understand, I can have a good feel for this site. Now someone else comes in and, junks up all my set points and all my algorithms. I'm going to undo that as soon as they leave.
Yeah.
And so it's not a question. And it's interestingly, it's because that tech cares and they take a lot of pride in their work that they're doing this, because what they care about is uptime and keeping product cold. But obviously those are really, really important outcomes, but they're missing that last outcome, which is energy efficiency.
Correct.
So that's where we have the misalignment. And then I think lastly, the visibility element here, these are great from a site-by-site perspective, but we don't have the ability with this methodology to see what's going on across sites, to monitor it remotely, to empower decision makers at corporate headquarters, or to really compare sites to one another.
Correct.
All right, let's keep on going here to better. So better is doing the on-site retrocommissioning work and then layering on 2 additional things, which are set point standardization across many sites. So saying, hey, here is a program that I'm going to apply across all 1,500 of my stores. The exact same suction pressure, the exact same float algorithm, the exact same defrost schedule, et cetera. So that very, very clear approach that is uniform across all stores. And then layering on lockouts. So lockouts meaning, hey, in order to change anything, you got to put in your password. Here's a screenshot of an E2 with the password. And so what that prevents, or that is meant to prevent technicians from coming in and changing things and reverting back to old methodologies or deviating from those programmatic set points that are standardized across stores. There's some big pros and cons to that, of course. So yeah, techs will always find a way around lockouts. Any examples of that you found in the past to be pretty common?
It's just, it's a difficult system where even if it's set up with a, hey, call this number if you need to make a one-time change, if somebody's not on the other end of that phone in your time of need, it burns up goodwill pretty quickly and frustrates the technicians, and they're going to do whatever they can just to kind of throw off the yoke of that particular demand. So it's just their time, they're extremely time constrained, and this is another layer. And if they feel like it's inhibiting them from their primary goal, which is keeping food at the right temperature, they don't have a whole lot of patience.
Yep. Yeah. At the end of the day, like, they're there to do a job, and that's get the food cold. Right. And if there are barriers in their way, if they're a good technician and they have pride in their work, they're going to overcome those barriers. And we can't fault them for that. They're just doing what they think is the best job that they can do. Yeah. And so, that's great for a lot of different stakeholders, not so great for the energy stakeholder in many cases.
Yeah.
Limited flexibility. So again, this is not going to lead to the best energy outcome for each individual store, even though it very well may lead to a better outcome for the fleet as a whole. And that's because you can't take the exact same strategy and apply it to a store in Virginia as you can in Chicago. It just doesn't make any sense because there are different weather patterns. There's many different factors which are impacting how those stores are built, maintained, operated, powered. Do you want to talk about that a little bit, Will? Any examples there?
Well, I think the one thing I kind of wanted to mention is that set point is really half of the equation. It's whether that's charting your course and setting your intention, but whether the system actually is able to achieve the set point. Is the set point right? Could it be better? Probably. And does the system respond, and can it actually achieve the set point? There's this whole, built environment aspect of physical work that's being done by tons of equipment. And sometimes it's just not responding to the set points that you've put in place. And so you can say, hey, the autopilot says we're going here, but there's this whole other realm of what's actually going on in the store that doesn't represent the platonic ideal of the set point.
Yeah. Oh, this store manager loves to leave the dairy cases open for 4 hours a day for whatever reason. Right. And so suddenly that standard set point just doesn't work for the facility anymore.
that, or, hey, it's targeting a 70-degree minimum, but there's a holdback valve and it's cranked, and it's, it can run the fans like crazy, but it's never going to get below 90.
Yep. So there's some real advantages here, but also some pretty major pitfalls. So let's move on to, I guess one last question here. Will, you had mentioned to me that Dalkia is able to get a lot of these benefits while still avoiding some of the pitfalls of, using a call center. So we are avoiding the lockouts, but then you're having this call center. Can you talk a little bit more about how Dalkia is doing that today?
So that's ventriloquizing a little bit for one of our partners who was already in a position to provide remote monitoring services. So that's actually a situation where this actually has been more successful than it could have been, where they have a 24/7 remote monitoring service, and they're layering on top of that, hey, there's a phone number you can call anytime you want. You can explain your specific problem, and you'll be given a window of time during which a Setpoint exception will be granted.
Cool.
So yeah, and
that
helps
today. Ventriloquizing.
Yeah. So in the end, that helps to not alienate the contractors on site, because they're getting a rapid response, but it doesn't solve for the Setpoint versus performance question.
Very good. So now I want to switch to our best bucket, as we're thinking about things, which we're labeling continuous energy commissioning. And so, Will, I want to hand this over to you because we view Dalkia as a leader in this. And Dalkia has put a lot of time and effort and brain damage into figuring this out, and in many ways solving this problem for the industry.
So
what it means to you.
Yeah, I think what we're talking about here is a semi-automated process that is, I think, continuous is sort of an ideal end state. That's definitely where we're targeting for, but it starts before you automate or make anything continuous. You want to make sure you're focusing on the right stuff. So we started with a goal and said, all right, we're going to engage meaningfully with the refrigeration and the HVAC system. What does that actually mean? And what are, let's start with what the right outcome would be from, we have, clear energy mandate, kilowatt hour, true result driven perspective on the world. So that's where we approach this problem for, but we kind of came up with hey, we want to deliver the exact required refrigeration effect at any given time in the store, whether case is coming out of defrost, whether it's January, whether it's August, whether there's a door on it, whether there's not a door on it. We want to make sure that the exact amount of refrigeration effect is delivered, and that you're not surging, and that we have close control over that. So you start with that, you minimize runtime of the compressors, and you minimize the compression ratio as much as possible in all seasons. So start by focusing on the right stuff. And then from there, I think we took that approach and said, all right, if we focus on these 4 measures within refrigeration, 4, 5, 6 measures, whatever it was, we think that that's going to basically account for 80% of the potential upside of energy efficiency within a given store. So we're going to focus on that, and we're going to create real-time analysis that's taking continuous data streams. We're pulling it off remotely and extruding it through this analytical engine right now that kind of assembles all the data into this dashboard. And so it focuses your attention right away on saying, is the set point right? Yes, no. Is the store doing the bidding? Yes, no. If not, why? And so rather than the iterative process that has been the industry standard for decades of individually logging into each store and verifying that something is right, and using a highly skilled human to do that, you're kind of just accelerating all of that analysis is being done in semi-real time. And hopefully there's a future state where this dashboard is fully assembled and it sits at the same spot where the data is being collected. So
we'll get there next.
Yeah, exactly. So that's a future state, but I feel like that's important. That's what we are setting out to do here. And I think the other, really important thing is that not only is there an appetite on the part of the customer for the energy savings, but the utility programs who have just hit the same key on the piano for the last 10 years, doling out incentives for LED upgrades, they want to go back to the well, working inside of these same energy intensive environments with the customers that they have longstanding relationships with, and they want to drive the next tranche of savings. But they have rules. The savings have to be real. And how do you do that? You create a legit site-specific energy model with a bunch of information that you collect on site, build the model, and then run the trend data straight out of the controller through your model and say, hey, it was this was as found, this was as left, and here's how the store is performing after we've done the work. Not only did it work the next morning, it's working 90 days out. And if there's any anomaly or if things start to drift, it all boils up to this dashboard, comes to our attention immediately, and then we can essentially go back to that site remotely, communicate with a service contractor who we have a relationship with, and try to nail that down. So we want to focus on the right stuff. We want to do the right analysis, and we want to use the highest and best use of people that are skilled in this industry to make critical assessments and decisions rather than all this kind of rote data gathering. So we want them in the operating room cutting. We don't want them out in the waiting room taking people's insurance info down and telling them that there's a 4-hour wait. So anyway.
If you guys can't tell, Will loves analogies. We'll be sure to get some more analogies coming soon here. I think that one of the really cool parts of Dalkia's model is doing this and figuring out how to kind of put together a program at scale by inserting some technology elements and then also using utility money to pay for this for a lot of your customers. Is that right, Will?
Correct. Yes.
Cool.
So if you are, the utility programs have evolved away from the widget model of saying you have X, put in Y, you're going to get this many dollars, and said, hey, how has the store been performing now? Prove it, establish a legitimate baseline, come to us later to say that you've done something, there's measurable impact on site, that it's changed the situation. Calculate that delta using, actual, engineering analysis that's backed up by sources that are widely understood, and on a measure that's been incentivized in some fashion by the utility for a while, and they will pay to make to defray the cost of that improvement.
Yep. So for I guess we have a really good number of attendees here, which I'm excited about. But for all the folks who made it this far, now it's time for our punchline, and that is, how do I do this at scale? And so our answer is use AI to do the repetitive tasks. It's not to do everything. It's to take a massive quantity of the repetitive work that needs to be done to enable this at scale, and then enable, just like Will was saying, enable doctors to be in the operating room cutting rather than in the waiting room filling out insurance forms. So in other words, have humans doing the really, really high value work and the problem solving work, while letting AI and cloud-based software do the repetitive stuff at a vast, vast scale in order to make sure those humans are using their time in the most viable way possible. And so what does this look like in practice? And so it's really a 4-step process, or that's how we're conceptualizing it at Axiom. Step 1 for us is gathering and cleaning and labeling all the data streams from the on-site controllers for refrigeration, as well as pulling in other data streams from weather forecasts, hyperlocal weather forecasts, local utility rate schedules, DR signals, whatever it might be that's available, and pulling that onto the cloud. The second step is, now that we've gathered this enormous quantity of information, which is way too much for any human to digest, using AI and using data analytics to process that information and pull out the actionable insights. And so an actionable insight really is either a problem or an opportunity. And when we're thinking about this entire opportunity through the lens of energy, this means finding high value energy savings opportunities. And then not only finding them, but diagnosing the root cause and then triaging them to figure out which ones are the most important. So in other words, prioritizing. and then batching them to make them very actionable for people who are sitting at a remote call center or for on-site technicians who are, they obviously can't visit 15 stores in one day, but they could visit 2 stores and do 8 things at those 2 stores. After that, it is getting the humans involved. And so if we're looking at, 10 million data points across 1,500 stores, and we're boiling that down into 25 opportunities that are very high value and high urgency, that's where the humans get involved. So they don't really need to look at 10 million data points. They can look at 25 things now and basically validate that those are real and they're not false positives. And then ultimately make that human decision of what the next step should be, what that action should be. And then also, of course, getting humans involved to go in, turn that wrench if that's necessary, or to authorize that set point change or authorize that algorithm change. And finally, there are actually a lot of things, a lot of problems, a lot of opportunities that can be solved automatically using software. This is optional though, and a lot of folks are not comfortable with that quite yet. And so in many cases, customers do have humans in the loop still, which I think is, it's a great trust building opportunity and exercise. Ideally, over time, we will build enough trust such that more and more of our customers are going to empower us to start making a lot of these changes automatically. We're doing that with some customers already. But the other piece here is that even if Axiom or the other, whatever cloud-based provider, AI provider is not making these changes directly for a customer, what we're able to do is package things up in a way that increases the likelihood that an early career technician, so someone who's really not qualified, maybe, I heard a story recently of someone who's a forest ranger for 10 years and then became a technician 2 weeks ago. And now he's on site trying to, keep a major retailer store online that's, at the brink of failure. We can help someone like that succeed by making sure that before they ever arrive on site, they know what the problem is, they know what the opportunity is, they know where it is in the facility, they know what the root cause is, they know what the steps are to address it. And so that's going to increase their likelihood of success during their first visit. It's going to decrease the length of time they spend on site, and it's going to eliminate, or it's going to reduce dramatically the likelihood of any sort of repeat visits for addressing the same issue. So this is how we think about addressing continuous energy commissioning at scale using technology, using AI. And so let's dig a little bit deeper into that. And Will, I want you to talk about this slide. Basically, why do you feel that it really is the combination of expert humans plus AI that deliver the best outcomes?
So it's funny. AI to me still means actionable insight, meaning that I think the AI part I'm pretty unqualified to comment on, but I think we're seeing that. If you do the right analysis and you do it in a automated and real-time fashion across lots of sites, we just know, having done this the manual and then the semi-manual way for a long time, the benefits are quite apparent, and we just know, hey, this is how we would be able to. We do 100 stores now, but this would be how you get to 500, and it's a major step function for us. And I think there's this kind of preventative healthcare analogy here that rather than, the status quo, which is basically a service tech, which is the ambulance service that shows up when the catastrophe has already happened, stabilizes and transports, and then, some sort of high cost level of care is administered in an emergency fashion. And in the end, it doesn't do anything to actually improve. It just maintains the status quo and doesn't change the course of that particular facility to seek out a new state of higher energy efficiency. We see this as hopefully being able to just change the workflow a little bit and to introduce energy efficiency, I guess, at the right point. So we're able to say, hey, here's a highly specific analysis of this one site that is unique from the site that's 5 miles away from it, and we know the differences because it's all built into the digital twin. We know that the piping configuration is slightly different over here than it is here, and you have to keep that into account when performing this analysis. But ultimately, yeah, we're just trying to get the highest and best use out of everybody's time, and make sure that that energy becomes one of these outcomes.
Yeah, well put, Will. So we wanted to really shine a spotlight on this and put some numbers on it. So I like Will's quote here on the left here. The model just doesn't scale. I guess maybe, Will, you can say your own quote.
I don't even remember saying that. It doesn't scale without an analytical engine to drive the actionable insights. So in the end, like our goal, we have to deliver a measurable impact. And it's just really hard if it's 10 of us working here in this little silo, and we don't have this tremendously valuable tool, which could come in lots of different forms, but just using the data and quickly sifting through it to point the light in the right direction is something that enables this to become valuable to a larger enterprise.
Completely, yeah. So when we're talking about without the AI tool, 3 to 6 months is the kind of the frequency with which folks are able to review sites. Whereas, with AI, this can be done almost instantaneously. So about 3 minutes. A team of, let's say, 4 people, for example, can basically serve at a high level an exponentially larger number of sites if they're empowered with this tool. Another really important piece that we haven't covered super closely yet is that we are able to, by using data, essentially by using AI, we're able to eliminate that on-site upfront retrocommissioning scope. And so that has massive advantages from a cost and kind of speed of deployment standpoint, because ultimately, rather than taking this one-size-fits-all approach and dispatching a technician for a couple of days to every single site, arguably there's 10 or 20 or 40 or 50% of sites that don't really need that. And so that's not the best use of capital for those sites. And so instead, a data-first, a data-driven approach enables the customer, enables the retailer to apply that same capital or arguably less capital to the opportunities that are the biggest and highest value at the stores that need it most. And then of course, there's just the human time element. So this is coming back to humans spending a lot of time gathering data, cleaning data, labeling data, visually inspecting data, versus taking all that stuff off a human's plate and allowing them to focus on the really high value problems of problem solving and reviewing the opportunities that have been flagged by AI. Very good. All right, so let's go into some examples, some case studies. Kyle, can you join and give a quick intro for yourself?
Yeah, of course. Hi, my name is Kyle Eastwood. I am the refrigeration, expert over here at Axiom. So getting right into this.
Kyle, you're invisible too.
Oh, it didn't kick on? Hold on a second here. There we go.
There it is.
You got to click it all right. There we go. Now we're on. So getting right into these anomalies, this is a suction float disabled. And this is really good because there's not really anything on the site controller side that would alarm when it's not floating. It's not there to alarm when it's not floating. It's there to actually float the circuit. So what's going on here is the actual float temperature is not able to pull down to where the float temperature set point is with the case that they're using. So just simply recommissioning this and changing some set points around could really help the float circuit and AI can actually see this as it happens versus the controller not able to see it.
Awesome. And so this ended up, this was resolved and ended up saving the customer about $2,600 per year on the energy bill at for this one suction group at this one grocery store. And I do see some questions rolling in on the Q&A, so keep those coming. Would love to, we have reserved the last 10 minutes to go through those, so keep them coming. Building on what Kyle was just talking about, we actually did maybe about a year and a half ago, put out a blog post, because at about 70% of the sites where Axiom, or over 60% of the sites where Axiom serves, we find that floating suction is not operating in the way that it is expected to be operating. So put another way, it's not on at all. or it's on, but it's not actually delivering value. And so this is kind of a staggering number from our standpoint, because whenever we talk to the energy stakeholders at retailers, generally folks are under the impression that floating suction and floating head and these various other energy saving strategies are operating and they're active. But in many cases, even if they're active, they're not actually delivering the desired outcome. And so what you just saw was one example, and actually the next one, I think it's another example of something kind of similar. So Kyle, you want to jump into this one?
Yeah, so this was a really cool thing to actually see happen. So the circuits, there's two circuits on the for the float that it was using for it, and it wasn't set up correctly to read the minimum temperature when using two circuits so they can defrost at separate times. So when they defrost at separate times, it was set to read average, and with it reading average, it was constantly driving the float down because it thought the temperature was going up. By simply just changing a set point, and then also we were able to raise the suction pressure a couple pounds too, which actually helped them save a lot of money. And just by changing that set point, you can see the difference right there of the suction pressure is not pulling down super low anymore, and it's actually maintaining just fine.
So again, this is an example of some suboptimal programming. Maybe the person who set up the store wasn't the same one who came in and maintained something a little bit later on, and ultimately making those changes, we were able to save about $2,700 for that one suction group per year. By making those changes, and these were the specific actions that were taken, and you can see the result right there. The lower suction pressure on the left here in blue, and then we're able to raise that suction pressure by a couple of psi and tighten it up quite a bit as well. Really good outcomes for system health and energy consumption at this facility.
And an interesting circumstance where if you did a quick glance at Setpoint, you'd say, "Yep, it's float. The float's engaged, set for 5 pounds. Everything's great. Let's go next store." And but in fact, you're comparing the trend data of actual performance with the set point and saying, hey, it's not actually delivering the intended result. Flag it, quantify it, fix it.
Well put, Will.
Yeah.
And so for we have 3 case studies today, so let's go into our third one here. Kyle, you want to take this one?
Yeah, so this was actually tripping off on fast recovery. Fast recovery set point is when the discharge pressure gets too high and it just wants everything running 100%. So no digital control or anything, everything just on 100%. And it kept tripping on fast recovery. Now the controller doesn't have alarms for that because the discharge pressure isn't above the actual alarm set point. It's just going into fast recovery, which isn't the worst in really hot ambient days, but it wasn't, this was, you could tell by the months of February, it wasn't that hot. So it kept on going to fast recovery. And what we end up finding is that the actual condenser programming for the VSD wasn't entirely correct, and it was reading the wrong points and not able to pull itself back down. And that was caused, we went to the logs and found it was caused by an incorrect program change months prior. Just at I think it was closer to the end of summer, we saw a program change that caused this. So during all winter, and then once we made the change, once we lured the customer, they made the change, technician went out, found out what was going on, the discharge pressure just started humming just along. And the spikes are okay. Those are actually hot gas defrost. So the spikes are just fine. A lot of people are like, but it's still spiking. Nope, that's fine. That's our hot gas doing its thing. And yeah, really, really, really good stuff.
Very good.
Will, you love talking about compression ratios. Hopefully this makes you jump out of your
Oh,
chair.
I love it. Yeah, it's my hobby horse. It's my one fixation. So yeah, this is fantastic. I love it.
We're able to drop the head pressure from 225 down to 160, maybe 170.
Yeah, perfect.
That's a lot less work for those compressors. Yeah, these before and after graphs are is one of my favorite things to show, is because we're delivering this at scale for hundreds and hundreds of stores and many cold storage warehouses as well now. And I guess one last piece here is that this entire conversation today has been focused on energy efficiency, but almost this exact same playbook of using data, using AI, and then supplementing that, the AI plus really smart humans, that same playbook can be used to dramatically optimize uptime, maintenance, and sustainability and refrigerant leaks as well. And that's something that Will, do you have any comments on that? Kind of broad.
No, I'm the energy guy, but I know all those are ancillary benefits and super closely related with all this stuff. So excited for the next webinar.
There it is. Perfect. All right. With that, let's jump into Q&A. And Joel, do you want to lead this portion?
Yeah, so our first one's sort of about the use of this in the industry. Is Axiom and other AI providers really focused on supermarkets, or are there other applications sort of in other cold environments that you're applying this framework?
Is this for Axiom or is this for me or Will?
I think it's mostly for you, but it's also, are we seeing sort of this framework of, people plus AI beyond just grocery stores? Yeah.
So with Axiom, today we're applying this framework to 8 major grocers throughout North America. So that's the US and Canada today. We're in hundreds of grocery stores. We want to be in thousands by the end of this year. We're growing really, really fast. And then we're also working in cold storage warehouses. So we're talking facilities that are anywhere from 100,000 square feet up to 1.5 million square feet with very, very large central refrigeration assets. Some of them are, some of them are the HFC refrigerant systems. Some of them are ammonia. Some of them are CO2 even. But those are kind of the 2 categories today. So facilities that are selling food, or facilities that are storing, processing, packaging, manufacturing food, or other refrigerated goods.
One for you, Will. You touched on it just a little bit, but can you go a little bit deeper into the role that utility incentives are having in promoting continuous commissioning and some of the opportunities you see moving forward, and maybe what it'll take to get them better educated on the current state of technology?
Yeah, so I think what's interesting is they have taken what was largely a custom approach geared around EMS replacement. So the replacement of older EMS with a new version of Danfoss, Emerson, Novar, RDM, whatever. And so they have been reviewing savings analysis that hinged on the benefit of the control system. And there would be like a crooked photo of a set point or some 15 minutes worth of trend data to say at the end of the project, yes, we did the project, the new intergalactic control system is installed, therefore energy savings, take our word for it, look at the model that we submitted. And so that's how these types of projects, these one-time recommissioning plus equipment install projects have been incentivized in the past. And I think that the utilities are realizing that they're only as good as what's the change that was made in the controller 5 minutes ago, or something mechanically that's being controlled by that control system that's no longer responding in the intended fashion to the set point. So and it's interesting. I should look in a little bit more closely into the history. So they shifted their focus to something called monitor-based commissioning, which said, hey, rather than tying yourself to the mast on this super onerous sub-meter everything process, which all the energy folks in this call have been subjected to and have had to figure out how to get a gazillion meters into panels that are all over the place in a facility that's super old, and you've got HVAC coming out of a refrigeration panel and lighting on a HVAC, it's a mess. That doesn't scale. And it's, in the end, it's hard to really, it's not great. And the programs were sort of crumbling under their own weight. And so many of the successful MBCX programs that we've engaged with, there's a lot of demand creation work on our part to say, yes, the grocery store is a good candidate, because there's lots of potential just by tuning the existing system. We don't necessarily need to go and take out X and put in Y and use this widget-based approach. We can just go and fix stuff and put it in the right direction, and then apply this continuous monitoring layer on top of it that alerts us to say that, hey, we got off on the wrong exit, and say, hey, we got off in this exit. Here's how we get back on the right spot. And so the utility programs have been kind of learning as we learn, and it's been a really great process, and we've met a lot of really cool, smart people that are psyched about this stuff. And I think we're getting to a point where we've standardized our method of analysis. They know what the trend data looks like. They know what the dashboard looks like. They are familiar with our energy models. Everything's kind of self-contained and nicely packaged. And man, that took a lot of time. But I think we were all pretty fixated on this end state where we have kind of this vernacular in place where we can communicate with the utility programs in a really legitimate way about what the impact is. So it's mostly kind of a Maryland to Maine phenomena, a little bit in Chicago, and then parts of the West Coast. But we think that what's really driving this the launching of more commissioning and monitor-based commissioning programs is the absence of future LED, or the absence of door on a case, simple, easy, widget upgrades. Those are all gone. What now?
So this is the new low-hanging fruit, tying everything together.
Correct. And it's man, it seems hard sometimes, but then other times you have a breakthrough and it feels like, I don't know, you got another rung on the ladder and you're grabbing the fruit, and it's it feels, it can be very, very satisfying.
A lot of these opportunities, especially where you go in and you change some algorithms at set points, which exist at almost every facility we go to, it's just like picking piles of dollars off the floor. It's just unbelievable.
Yeah.
So, sorry. So both of you had talked about, the relationship between getting these actionable insights and how you deal with the people with the boots on the ground. A question came in sort of along those lines. It's, as we move toward AI-driven refrigeration, how do we ensure that we're not creating sort of a black box problem where the inner workings are creating, insights and they're not understandable by the human operators? Like, what are some of the safeguards to prevent that?
Yeah,
So-
I can start there.
Go ahead.
I think that, that at least I've had a lot of conversations with folks who, wax poetic about how they used to fix their cars. But now with, the new kind of computer-driven diagnostics, it's impossible and everything's all covered up in shiny plastic, especially the electric vehicles and the hybrids and things. So that's not really the direction that we're going, at least at Axiom. Instead, we're taking the approach of understanding that our key stakeholders and the folks that we work with and support are experts generally. And so empowering them by giving them more access to data rather than less, more visibility rather than less, that's been the approach that we've taken. So do they have to take advantage of that visibility? No. Do they have to log into that 11th dashboard that they need to remember a username and password for? No. But it's available, especially for the folks who want it. And so at the end of the day, the real value is going to come in how is all that data that's become available for the first time, these 10 million data points, how is that being used to drive actionable insights and then ultimately actions that drive business outcomes? That's where the real value is. But from a visibility standpoint, we are moving away from the black box model, which is, a bunch of data locked up in an on-site E2 or on-site AKC 255, to something where you can look at all the data for all time on your iPhone or on your Android in your pocket anytime across 1,000 sites.
Yeah. And totally, the key to this is that if this software platform exists, on the desk of the technical buyer at the corporate level and is not pushed out as a tool to help people, it's just not going to be. It's not set up for success. And ultimately, this is something that we're just trying to provide a higher and better use for human and economic capital, and try to focus on the right stuff. And so ultimately, I think, Amr, you mentioned you have like a virtual technician app. Like there needs to be a user experience, whether it's Axiom or anybody that wants to sort of partake in this software-driven, monitor-based commissioning, remote, analytical engine type exercise. The success is really critically hinged on having a user interface that people who are actually working in the store can use. And And if you have this sort of separate work stream that's completely siloed, or maybe there's like a small mode of interacting with service contractors through sort of unintelligible work orders that come out of, like, that's just a really super quick way to burn up goodwill. And yeah.
As well as false positives. That is a great
Yeah.
way to burn up goodwill pretty quick. You give them
Exactly.
$50,000 worth of value and one false positive, and
That's it.
Are you a good partner?
Exactly.
All right, I think we got time for maybe one more, Joel.
Yeah, I think we've got two that have come in. One can be relatively quick for you. Amrit, could you describe what the Axiom digital twin actually does, and sort of how that what the goals?
So the digital twin. So the first step is modeling the refrigeration system. The objective is to model the refrigeration on site in the cloud in real time. And so, put another way, you have an exact replica of your refrigeration system that's in your machine room and on your sales floor operating in the cloud. And basically, that starts with a idealized model. So, looking at physics, thermodynamics, the basic rules here, and making that physics-based model. But then feeding in the hundreds or thousands of real-time data streams from the on-site controllers, from local weather, from local utilities, et cetera, and feeding all that data into the model by processing it with machine learning algorithms. And so, put another way, we take that idealized model, which could never exist in the real world, and then we tune it up with real data in real time, using machine learning models in order to make it really precisely representative of what's happening on site. So that's kind of step one, is we have this super accurate model, and then we can use that model to identify deviations between what's actually happening on that site, as shown by data, versus what should be happening on that site according to the model. And we can do that in real time. And those small deviations are often leading indicators for opportunities or problems on site.
Yeah.
So that's how we get ahead of a lot of things.
And one of the more impressive things, Amrit, was when I saw the trace function. So in the stores where you do actually have access to on-site energy monitoring on a rack level or condenser level, where you have real-time digital twin that's taking all the mechanical schedules of a facility, the evaporator loads, and all of the outside conditions, and then all of the set points. When you're actually able to mirror in real time the actual outcome on the energy meter with your simulation of the digital twin, and they're insanely close. And that was a pretty that for me was a fairly transformative moment to see, like, holy cow, you actually did it. That's incredibly powerful. Like, this can be trusted, and this is highly credible.
Awesome. I appreciate the comment, Will. And so with that, we are out of time today. So I want to thank everyone for attending, and the recording will be emailed out to everyone who's here or who registered. And I would strongly encourage anyone who's interested to reach out to Will, reach out to me, if you have any questions or interested in learning more about Dalkey or Axiom. But we really appreciate you being here and being part of this industry conversation, and carving out a portion of your day to be with us. So thanks all, and have a great Wednesday.